Okay, today's class will be more of understanding the concepts behind the last assignment which I've given. While checking the copies, I found a lot of people did not get the concepts clearly. Hence this particular video. So going for the first question, frequency of each four-digit number. This most of you have done it correctly because I believe I've already taught you this particular program, that is finding the frequency of each different set of numbers. So in this case, what we did was after entering the 10 numbers, we'll start a for loop from x equal to 1000. Because why 1000? Because 1000 is the smallest possible four-digit number, because I am supposed to accommodate every possible four-digit positive numbers, because I need to check every possible four-digit numbers which are present in the array or not, and it will go till 9999, that is 9999. And here what I'm going to do is I'm going to check whether the number which is, that is four-digit positive number, whether it is present in the array or not. So this particular loop is for the array. I'm going to check whether it is present in the array or not. So here, if a of I is matching with x, that means since it is matching, I'm going to count how many times it is matching. So at last, if c is greater than 0, that means the number, that particular four-digit number exists within that array. In that case, I'm supposed to print that number. Along with that, I am supposed to print its frequency. This is what I am supposed to do. So I am going to print the number along with its frequency. This is what we are doing. So we are getting each four-digit positive number and we are checking whether it is present in the array or not. Now, this particular program, most of you have done it correctly. I have no problem with this. Some of you did not get it. So this is what we do to find the frequency of each four-digit number. Now, suppose, say for example, I ask you to find the frequency of each three-digit number. What are you going to do? You're going to only make it 100 and 999. Why? Why not, 150? Why do we begin with 100? Or for the four-digit positive number, why on earth did we start from 1000? Why did we start from 5000? Even that's a four-digit number. The reason behind this is 1000 is the smallest possible number and 9999 is the largest possible four-digit number. So to accommodate every possible four-digit number, we use this smallest possible number and largest possible number. Now look at question number 4. The question number 4 states that input 10 numbers into an integer array and find the frequency of each number. So here for four-digit number 1000 to 9999. If it is three-digit number 100 to 999. If it is two-digit number 10 to 99. If it is frequency of each number. Now since I did not specify which number's frequency, I need to find the range of numbers in the array. What are the possible range of numbers? So how do we do that? Very simple. What we are going to do is we are going to find the largest and smallest number in the array first. Why? Because every number will be between the smallest to largest number, both inclusive. So what we are going to do is we are going to run a loop from smallest to largest number. And every time, so first you need to find, obviously don't forget that, don't, after the input, don't start with this part. First, find the largest and smallest. After that, you run the loop from S, where S indicates the smallest number in the array and L indicates the largest number in the array. So this loop will accommodate all the numbers between the numbers in the array, between the smallest to largest number. And now we are going to check whether it is present in the array or not. If it is present, I am counting how many times it is present and ultimately I am printing it. So this is how we find the frequency of each number. However, there's a but over here. This is not a very good technique. The reason behind this is if the range of numbers is too big, huge. For example, for an array of 10 numbers, the smallest possible number I input is minus 10,000. And the largest possible number I input is 32,000. Now you see the problem. The loop is going to run from minus 10,000 to 32,000. I think it's easier to count manually for finding the frequency of each number in an array of size 10. Isn't it? Instead of making the computer work so hard, running a loop from minus 10,000 to 32,000, it will take quite a bit amount of time. So this is not a very good idea. So how do we do that? We'll do this later on. Before that, we'll go for the next question. Okay, now we'll start with the second question. That is, input 10 numbers into an integer array and find those single-digit positive numbers that are not present in the array. Okay, So single digit positive numbers, what are the possible single digit possible numbers? That is 1 to 9. So here we are going to apply the same technique. We are going to check whether it is present in the array or not. If it is present and putting a counter, I could have simply written c equal to 1. I have written a counter, no issues with that. So now, if the number is not present, after coming out of this array loop, that is after checking with all the elements in the array, what is the value of c if it is not present? Naturally 0. So if c is 0, so we'll put a check. If c is 0, then I'm going to print the single digit positive numbers. That's it. This is what we are supposed to do. And question number 2. This is what we are supposed to do. We take a single digit positive number, check it whether it is present in the array or not. If c is 0, that means it isn't present. In that case, print that single digit positive number. I believe all of you are getting it. Now we are going to go for the next question. That is, input 10 numbers into an integer array and print each number only once. Now, irrespective of the number of times present in the array, you are supposed to print only once. Now, we'll understand this particular question, and then we'll try to understand how to go about it. Suppose these are the numbers, say 4, 12, 9, 4, 4, 9, 12. What should be the output? The output should be, every number should be displayed only once. So 4, the next should be 12, the next should be 9. That's it. Nothing more than that. Now the question arises, how do we display every number only once, irrespective of the number of times it is present over there? Now what we are going to do is, we are going to take a number and we are going to display it provided I have not displayed it before. Now how do we do that, or rather how do we check whether I have already printed it before or not? What we are going to do is, we are going to take a number and we are going to check whether the number exists before the current position or not. If it exists before the current position, that means I have already displayed that particular number. So what we are going to do is, take 4. Does it exist before it? No. So we are going to display it. 12. Does it exist before it? No. So I am going to display it. 9. Does it exist before it? No. So I am going to display it. Next comes 4. Does it exist before it? Yes, it exists. So I am not going to display. Again 4, it exists. I am not going to display. 9, it exists before it. I am not going to display. 12, it exists before it. I am not going to display. So what I am going to do is, I am going to check with all the numbers previous to the current position. That is, suppose say for example the current index or current position is 5. I should check with all the numbers previous to the current index. That is from 0 to 4. If I am at 5th index, I should check with all the numbers from index number 0 to index number 4. So that is what I am supposed to do. Similarly, if I am at index 7, I should check with all the numbers from index 0 to index 7 minus 1, that is 6. So how do we go about it? We'll run a loop, see how to do. Here we'll use a flag variable to mark an indicator, and we'll run a loop starting from 0 till j is less than I. So whatever is the value of I, this loop is going to run 1 less than that. And in case there is a match, if a of I is matching with a of j, then what am I going to do? I'm going to raise a flag. So f equal to 1. So now what we're going to do is, so I believe you can understand, suppose say for example the value of I is 4. That means the number at the 4th index. So this loop is going to run from 0 till less than 4. That means from 0 to 3. If there is any match, the value of f is 1. It's always preferable to put a break also out here. Even if you do not put, still it is going to work. Now you see, whenever there is a match, the value of f will be 1. So if f is 0, what does it mean? The number do not exist prior to the current position. That means before the current position. In that case, you display that particular number. So C out a of I. This is what you are supposed to do. See how simple? In that case, you are supposed to display the number at the ith index if it do not exist before the current position. I believe you got this. Now we'll go for the last question. That is finding the frequency of each number. That is, input 10 numbers into an integer array and finding the frequency, and to find the frequency of each number in the array. Now, without using the technique which we learned earlier, that is finding the largest and smallest and then running a loop from smallest to largest. So we are going to use a different technique. So first of all, we are going to learn that. So what we are going to do is, we are going to take a number and compare it with all the numbers and check how many times it is matching. And then we are going to print its frequency. So as simple as that, let's see what happens. Take the first number, compare it with all the numbers. How many times 4 is present? 3 times. So we are going to print 4, the frequency is 3. See, simple. Again, we get 4. Now the problem arises. Again, you are going to print 4 and it's going to print its frequency 3. Next come 12. It's fine. It's going to print frequency. Okay, frequency is 2 in this case. 9. Okay, frequency is 2. But again, when it comes to 12, again it's going to print the correct frequency, but again it's going to repeat itself. So every time the number exists, it's going to print its frequency. That means we have a problem with the output. Though the output is correct, it is repeatedly printing and printing the same thing, which is absent, which is not required. What we need to do is, if we have already printed its frequency, we should not be printing its frequency. That should be kept in your mind. So what we do is, we take a number and we should first identify, or we should first find out whether I have already found its frequency or not. If I have already found its frequency, that means I am not supposed to find its frequency. So 4, did I find its frequency before? No, so I am going to display its frequency. Next, what happens? Next, what do we have? We have 4. Is the number 4 exist before it? Yes, that means I have already found its frequency. So I have not found its frequency. 12, does the number 12 exist before it? No, that means I got the number for the first time and therefore I am going to check how many times it is present. So I can print its frequency 2. Next comes 9. Does the number 9 exist before it? No, so I am going to check how many times it exists. Next 12. Does the number exist before it? Yes, so I am not going to print it, find its frequency. 9. Does it exist before it? Yes. So this is the technique which is involved. Now the question arises, how do we check whether it exists before it or not? We'll apply the same technique which we had learned in question number 3. That is existing, whether the number exists before it or not. For printing each number only once, the same trick. So we'll start a loop for I equal to 0, I less than 10, I plus plus. We'll use a flag which is initially 0, and here we are running a loop starting from 0 till less than I. Now what is the reason behind this? The reason behind this is, this particular loop is going to check whether the number exists before the current position or not. So it's going to check whether the number exists before the current position or not. So here I'm going to put a check. If A of I is matching with A of j, that means, what does it mean? The number exists, so f equal to 1. So if f is 0, what does it mean? The number do not exist before the current position. So if f is 0, it means the number do not exist. So now I'm going to check how many times it is present. So I'll use a variable say c, where c is initially 0. I'll run a loop from ith index, that is the current index, till the end. And here we are going to put a check. If A of I is matching with A of j, I'm going to check how many times it is matching C++. So now I'm going to display the number, that is A of I. Along with that, I'm going to print this frequency, that is frequency is C. Don't forget the handle because there are a lot of output. And then the if block ends, and ultimately the for block ends. So this is what you are supposed to do. So what did we do? We took a number, checked whether this number exists before the current position or not. If it do not exist before the current position, it means I got the number for the first time. And if I get the number for the first time, the value of f will remain as 0. So in that case, from the current position, you can also start from 0, but it will be a complete wastage of time because it do not exist before it. So from the current position till the end, we are going to check how many times it is matching. So ultimately, we are going to print the number, along with it, its frequency should be displayed. Thank you. I believe you understood the solution to all the programs and removed all the confusion which is there in your head. A lot of people this time had problems with the question, so that is why I had to discuss this.